Okay, hello everybody. My name is Jeff Koss, and I'm here today to give you guys a presentation on artificial intelligence and the algorithms and design patterns that go into it. And to do that, I'm going to be using a library called ML Agents with a video game engine called Unity. And before I begin, there is one thing I want to make note of. I have a noisy parrot, a bird, and he's sitting next to me, so he might actually chime in every once in a while here. I apologize for that, but there's nothing I can do about it. He's sitting next to me, and I can't move him right now. So, with that said, I hope that's not too much of an inconvenience. Anyway, let's move on. So, you're here to learn about artificial intelligence and machine learning with the Unity game engine. So for this presentation, I'm going to walk you through three different scenarios that I liked. They're going to take between 5 and 10 minutes each. I will try to make it as short as possible. I am hoping that you guys are going to gain some insight on artificial intelligence and machine learning and how you can adapt this for your different projects. Now with me, I'm a robotics major and embedded systems design major, so this is going to be very valuable to me when designing robots, and you'll see why in a little bit. Okay, so let's take a look here. So I have to evaluate three of these examples. Now, the ML Agents is a library for the Unity engine, and it comes jam-packed with different examples. You can pick all of these different examples here and more, basically, to go through, and it's really easy to do. So I will pick one easy one medium length one I would consider medium, and one harder one. So for the easy one, I chose this one. It's called push block. And what happens is you have this actor right here, this little blue guy, and his job is to take this white square and move it into this green area here, much like a soccer player, or if you're in Europe, a football player, would do in order to score a goal. Now, each time he scores a goal, he gets rewarded with points. Points are like food in this, and he wants his reward, he wants his food. However, every time he moves, he gets points subtracted. So the goal here is to get the ball or get the square into the green area using as the least amount of moves as possible. And we don't do that just once. We do that multiple times at the same time. There's going to be maybe 10, 15 of these running at the same time, and it's all running together to help get the best case scenario in the least amount of time, which I think is amazing, because back in my day, this was the stuff of science fiction. So let's go ahead and let's take a look here. But first, I'm going to need to load that one up. So let's go here. And this one was called push block. Okay. I need to get rid of this one. And we need to use this one. So in each one of these scenes, we have a bunch of different actors and a bunch of different levels. Now, as you can see here, all of these are levels, okay? And they're going to run simultaneously at the same time, although they're independent from each other. You're going to find out that no two actors are going to be doing the same thing at the exact same time, for the most part. There's probably always an anomaly, but I have yet to see that. Okay, so here's what the scenario looks like. And if we maximize it, as you'll see, there's an actor, there's your white square, and there's your goal line. Now, each time this guy scores a goal, it's going to change position. So he's going to, just because he did it one time, doesn't mean he's going to be able to do it the same way the second time, because the goal positions are going to change. So the algorithm's got to think for themselves on which the best case scenario, and it basically logs that, and eventually it'll figure it out for each way. So let's take a look here. Takes just a minute to load up, and we'll get going. I think it's amazing how a video game engine can do this. So, oh, sorry about that. Something happened there. Okay, so as you can see, he's finding the ball and he moved it, and each time he gets it on the green line, it scores, and it symbolizes that by turning the play area green. So now you can see he's getting better and better at it, right? Well, now he's got to figure out that way. So now he's like, hey, what's going on? But see, he knew that way, and he knows that this way is going to be the easiest way. Now, let's take a look here at what's going on in the background. All of these, look at that, all of these are doing the same thing at the same time. But none of them are doing it exactly the same way, because all of these things are different. You have different goal lines in different areas. All of this is going on in real time, so just think about the computation that's going on here. It's absolutely mind-blowing to me that we can do this. Back in my day, this was science fiction. So, I mean, this has got a lot of application to it, because one of the first things that you think about when you're doing an artificial intelligence is, how are we going to get a thing that we write, a program that we write to think for itself? And this is how you do it. You know, you have a situation that needs to be solved, and you have a goal, and you solve that goal by offering a reward. So the artificial intelligence wants to get these points, and it doesn't want to get low points. It wants to get the highest points possible. So it tries to figure out how to do this in the least moves possible, and it remembers it. Eventually, we'll find the best case scenario, and I'll be able to use that, take that data and use it for something else. And I think that is just amazing. So, moving on though, let's move on to the second one. Now the second one here I chose because I like this. This is the spider one. This is the crawler one. And the reason why I like this one is because I'm a robotics student, and these types of robots interest me greatly. I really want to design a spider type robot, you know, a quadruped robot. And this basically how this one works is you train this four-legged robot here to move and collect these green squares. Each time he collects a green square, he gets a reward, but every time he moves, he's getting points subtracted. So much like the other scenario, he does that. So, but we're not going to do that one. This is a surprise for you. We're going to do this one. The 3D balance ball is my second choice, actually. It was a toss-up between this one and the crawler one. But I chose this one because this addresses a very unique problem. And what this is, these actors have to balance this ball on their head and make sure it doesn't fall off their head. So they have to maintain basically this ball at the center of the gravity of the center of this in order for that to happen. This is very valuable because this is one of the first steps in biped robots. In biped robots, you have to make sure, or one of the things we have to solve is the gait of the robot, which means how it walks. And, well, we have to keep our center of gravity in the middle, otherwise we're going to fall over, you know. And I thought that this would be a great example of that. I'm highly interested in this. I've been highly interested in this type of theory. Ever since I was a little kid, I used to play a game called BattleTech. And it was one of those games with, you know, pieces. And you basically were in these robots that walked upright, and they had all kinds of massive weaponry, and you try to blow each other up with it. But anyway, let's take a look at what's going on with it. Let's go ahead and let's run the scenario. It's called 3D ball. So let's put that in, and we'll remove the other one. Okay, so with this one, you have, like I said, you have a bunch of these little actors, and they have to balance the ball on their head. So let's see how this works. Okay, let me maximize the screen here. So you have all of these actors trying to balance the ball on their head in different ways because all of these scenarios are different and they're all doing it in real time. Eventually, you're going to get one that the ball's going to fall off and it's going to learn from that, and then it's going to keep doing it. Two, we finally get a robot that has mastered this, or not a robot, but an artificial ML actor basically that mastered this and is able to do that. Eventually, one of these balls is going to fall off, but it might take a while. So we'll see. Look at this one. This one's kind of moving around a lot. This one's kind of going to the edge. This guy up here, he's trying to get that to come back down. Yeah, see that? Boy, these guys are acting pretty smart. I mean, this has got a lot going for it because after this, we'll be able to take this information and use it. Think of a gyroscope, you know, and how a gyroscope would move. We could train a gyroscope to move these in certain directions to keep that ball centered, you know, and that right there is probably the answer to a biped robot. So that is amazing. I mean, very useful. And we'll move on to the third one. So the third one I kind of picked because it was fun. Let me pull it up. Although this one was pretty cool too. The food collector one is really neat. I encourage you guys to download this yourself and try it out and see what you guys come up with. There's a soccer one. There's a goalie versus striker. There's a cool one. There's your biped robot right here, the walker. So this one basically, he starts, you know, kind of crawling around and limping with his leg, and he's got to find this object and get to it in so many turns. And if he does it, he gets points. So pyramids, match, that's a cool one. Sorter is really cool. Cooperative push block. Dungeon escape, this is the one. Okay, I have a very, very passionate love for this one. Excuse my language, but this game is kind of a throwback to me in so many ways. There used to be a really popular game out there called Adventure, and I loved it. And it was for the Atari 2600. And basically what you had to do is you had to go through this dungeon and find a key to unlock yourself and get out. But or unlock this castle to get into it. But you had to avoid this dragon, because if the dragon caught you, he'd eat you and that'd be it. So in this game, you have 3 actors, okay? 3 ML actors. And how this works is one of them has to make a sacrifice in order to kill the dragon or to get rid of the dragon, and the other 2 have a chance to get the key to unlock the door and go to the next level. So all 3 of these actors are thinking independently on how this is going to work, and they're all working together to accomplish this goal. Now, if they don't do it within a certain amount of time, the dragon comes back and the level's reset. Okay. I think that is neat because you have more than one AI actor in one scene making independent decisions. So let's see how this goes. Let's see if these guys can do it. I think they can. All right, let's remove that scene. So with this one, these things are all stacked up on top of each other. Look, you have all these different levels, and they're all going to be doing different things at the same time. But let's take a look at this level and see what is going to happen here. So you have 3 AI agents, a dragon, and a key, and the door to get out. Okay, so that kind of happened fast. So as you can see, this little rip sign, grave. So one of these guys had to make a sacrifice in order for the dragon to drop the key, and then the other guys get the key and they go into the door and then get the next level. If that doesn't happen in time, like these guys are all confused, then the dragon will come back and they'll lose. So all three of these guys are figuring out, you know, what's the best way, who's going to make the sacrifice, and how's that going to better the other 2. And that's pretty neat. I mean, I think that's amazing. Look at that, they're learning. And to prove that, let's take a look at the scene. Look at that, all of these levels. They're all doing different things to achieve the same goal. You know, it's the chaos theory type of thing, which I think is really neat. Pretty cool, guys, don't you think? So yeah, this does have a lot of applications to it, you know. But anyway, that's the conclusion of my presentation, and I hope that you guys took away something from this, that machine learning, artificial intelligence, has come a long way. I mean, we're at a position in our lives now with this. It's opening up a lot of new doors, and it's a brave new world out there with this. And I am very, very happy to be a part of it. Anyway, guys, thank you very much, and have a wonderful day.